Hi guys, today we're going to be looking at a question on electrostatics. A small sphere, y, carrying an unknown charge is suspended at the end of a light inextendable string which is attached to a fixed point. Another sphere, x, carrying a charge of 6 times 10 to the power negative 6 coulombs on an insulated stand is brought close to sphere y. Sphere y experiences an electrostatic force and comes to rest 0.2 meters away from sphere x, with the string at an angle of 10 degrees with the vertical as shown in the diagram below. Question 7.1.1. What is the nature of the charge on sphere y? Choose from positive or negative. As we can see, sphere y comes to rest 0.2 meters away from sphere x. Therefore, they are not actually attracted and are actually being repelled, as due to gravity, y would fall dead center. This means that y has a positive charge, as two positive charges will repel each other. Question 7.1.2. Calculate the magnitude of the charge on sphere y if the magnitude of the electrostatic force acting on it is 3.05 newtons. To calculate this, we can use the formula F is equal to K Q1 Q2 all over R squared. We then know the force. K is a constant. We have the charge of the one sphere being 6 times 10 to the power negative 6. And we are trying to calculate, we can say Q2. We have the distance between them being 0.2, and this is squared. And when we rearrange and plug all of that into the calculator, we should get 2.26 times 10 to the power negative 6 coulombs. Question 7.1.3. Draw a labeled free body diagram for sphere y. So we can say this is sphere y. Sphere y experiences a tension at an angle as it is being held by a string. It experiences an electrostatic force by sphere x away from sphere x, as they both have positive charges. And then with all objects, it has a gravitational force, its weight, down. Question 7.1.4. Calculate the magnitude of tension in the string. As we know, the object is at rest. Therefore, F net is equal to 0. This means that the horizontal component of the tension must be equal to the electrostatic force. And to get the horizontal component, we take sine 10, as we know that this angle is 10 degrees. We then plug in our values, and when we rearrange and solve for t, we should get t to be equal to 17.56 newtons. I'm going to do the next question on a new page so you can see it more clearly. Question 7.2. Two small charged spheres A and B on insulated stands with charges 2 times 10 to the power negative 5 coulombs and negative 4 times 10 to the 5 coulombs, respectively, are placed 0.4 meters apart, as shown in the diagram below. M is the midpoint between spheres A and B. Question 7.2.1. Define the term electric field at a point. Electric field at a point is the electrostatic force experienced per unit positive charge placed at that point. Question 7.2.2. Calculate the net electric field at point M. We can first start by calculating the electric field at M due to A. So, due to A, we can say that EA is equal to K Q over R squared. K is a known constant. We have the charge of A. And since we know the total distance is 0.4, halfway is 0.2. If we plug all of that into the calculator, we should get 4.5 times 10 to the power 6 newtons per coulomb. We can then do the same with B, using this formula again, the distance also being 0.2 as it is the midpoint. And if we plug all of this into the calculator, we should get 9 times 10 to the power 6. We can then take our two values, 1 and 2, and add them together. And in total, we should get 1.35 times 10 to the power 7 newtons per coulomb. And that's all for this video. Thank you.